Good afternoon, everyone. Uh, let's go ahead and get started. Can everyone hear me okay on Zoom? Could you give me a thumbs up or a message in the chat just to let me know? Perfect. Thank you. So my name is Barbara Martinez Neda. I'm the research data scientist here at the library. And today I'm going to give you an introduction to data cleaning for machine learning purposes using Python. So some of the things that we'll talk about can be more generalizable to other sorts of applications for data cleaning, but we'll focus a little bit more on those applications necessary if you're interested in doing machine learning tasks with your data. Just a little side note, this presentation is being recorded, so we are going to make it available on our YouTube page at the end of the session in about a week or two. So let's go ahead and get started by first talking a little bit about what data cleaning is. So data cleaning is the process of detecting and correcting incomplete or inaccurate records from a data set. In this little graphic here, I have how we have a data file that might not be too clean. It might have some missing records. It might have something that we need to take care of. And by taking care of some data processing and data cleaning steps, we can end up with a clean data set ready for multiple applications, including machine learning. So clean data matters because essentially when you standardize the inputs to ensure accuracy, consistency, and reliability, you are making sure that your data is going to show exactly what was captured in that initial data gathering stage. So here we have a clean data set that has already gone through some of the steps that we'll talk about today. And that data set can be used for things like data analysis, data visualization, or machine learning. Particularly talking about machine learning, we need to make sure that when we clean our data sets, we need to make sure that our data ends up being accurate, consistent, complete, free of outliers, and in a compatible format for ML algorithms. And the reason that we do this is that when we give a data set to a computer, it might not really know how to handle, like, for instance, some machine learning algorithms don't really know how to handle non-numerical data. So we need to make sure that we take the data processing steps to get it in a format that the algorithms can understand. In other cases, algorithms don't really know what to do when a specific piece of information is missing from a record. So you need to take the steps to make sure that your data set is complete, doesn't have anything missing, doesn't leave anything up for interpretation for the machine to have to make a guess. You take care of those steps so that then your model can have the best possible performance because you have taken those extra steps to prepare the data set. So our plan for today is to explore how we can prepare our different types of data for machine learning. We're gonna get started using Google Colab. We'll go through a quick demo together with different types of data, and I'll share some next steps that you can take at the end of this workshop if you want to continue learning about data cleaning and different applications that you can do. Because when it comes to data cleaning, data processing, there's, I would say, like a general pipeline you can follow, but I do think that the steps that you're going to take and the decisions that you're going to make are going to vary tremendously based on the specific data set that you're working with. So I would say this is almost like a starting blueprint that you could start with, but then looking at some of those additional resources can guide your process for your data set. And I'm also here as a resource, so you could always book a little consultation with me or a meeting and we can talk about it a little bit more. So to get started, we're going to be using a Google Colab notebook. If you would like to follow along, you could enter this tiny URL on your search bar. If you don't want to follow along and you just want to watch what I do on the screen, that's totally fine as well, but you will have access to the slides and this link so you can experiment even after the end of this session. So if you are going to follow along, you are going to grab this link, tinyurl.com/S26 data cleaning ML. If you're on Zoom, I will go ahead and drop the link right there. So we are going to open up a new tab, drop our link on the search bar, And this is going to open up a Jupyter notebook in the Google Colab platform where we're going to be running our code. So this file that you're seeing is something that you have to make a copy of. So let me make this a little bit bigger. To make a copy of this file, you're going to go to File, Save a Copy in Drive. It's going to create a copy for you. And then this copy of data cleaning 4ML is going to be saved on your personal drive, so you can go ahead and access it after the session's over as well. So I'll go ahead and close the other files just to avoid confusion. And this copy of data cleaning is where you could run stuff if you're going to run it right now or after the session. So let's go back to the slides for a minute. So the first data set that I'm going to be working through with you all for the data cleaning steps is going to be a tabular data set. Tabular data set is a table, it's a CSV file, an Excel file, probably one of the more common types of data we might be familiar with. We're going to be using the Titanic data set for our sample use case today. This data set essentially contains different information about passengers on the Titanic. We can see their passenger class, we can see their sex, their gender, how many siblings and parents and children they traveled with, how much they paid for the ticket. And the most important flag or feature in this data set is the survived flag. So 0 means that the passenger did not survive. 1 means that yes, they did survive. I also chose this data set, well, not only because Titanic's actually my favorite movie, but also because when you're learning about machine learning and you're looking at things online, like tutorials and things like that, this data set is actually a very popular one that people use to predict whether a person survived or not based on all the information we have about them. So they might set up a classifier using a person's ticket class, sex, age, and all this other information. Can we make a prediction about whether they survived or not? And we won't go a whole lot into the prediction side of things today. There is going to be a session in like 2 or 3 weeks. I'll have the information at the end where we will discuss intro to machine learning, and I'll likely touch on this data set just because of the classification you can set up. But today we'll talk about what cleaning steps we can take in this tabular data set to make sure it's good to go for those machine learning steps later on. So when you process tabular data, particularly for machine learning, we need to make sure that we're removing or handling missing, duplicate, or irrelevant data. So I have here a brief list of some things you can consider. The more common one that is probably also like used for non-machine learning, I would say, are like these first 2 or 3, where you are handling missing data, outliers, duplicates. You might handle data types where like maybe one column has data that's both a string, like text, or a number, like an integer. And maybe encoding categorical features where you represent things like strongly agree to strongly disagree with the numbers 1 through 5. The 2 that I would say are most relevant for machine learning are these 2 at the end: standardizing or normalizing your data. And I'll talk a little bit more in the example. And the last one, balancing your data set. So 2 libraries that we're going to see in the notebook are the pandas and the scikit-learn libraries. Pandas library is most known for like data management and data processing capabilities, while the scikit-learn library is what I would consider the go-to for traditional machine learning classifiers. And since you can train classifiers with this library, they've also built in a lot of code into their library for you to be able to process those data sets as well. So with that, let's go ahead and explore some of these in the Colab notebook. So we are going to go to our copy of file. And just in case you haven't used Google Colab in the past, Colab is kind of like how we have Word docs on our computer and then Google Docs online. Very similarly, you could have Jupyter notebooks to run Python on your computer, or Google Colab notebooks to run it online. It's a service provided by Google. And in these notebooks, you can have text cells, just like these, where you can write in plain English. And you can have code cells just like this one with a little play button on the side to run the code inside of that cell to allow us to run code in specific sections. So that's one of the biggest reasons why Jupyter notebooks are very useful for data science, because you could test out different things. You could see the result for one specific small block of code rather than having to run your entire program at once. So the very first step you're going to do is loading your libraries. So we're going to import the pandas library, sklearn, as well as some other ones that we'll discuss later on called NLTK and OpenCV. So you're going to see a ton of stuff here. Main thing you need to know is that we are importing specific libraries and we're giving them an alias for us to refer to them when we start coding. So I'm going to hit the play button to run this cell. And right now this one might take a little long because we're downloading some stuff, we're importing other stuff. But the main thing we need to look out for is a green check on the left to tell us that we've successfully imported everything that we need. So while that's going, let's see, yeah, we can see that things are being downloaded. Give it a little bit longer. And the green check mark tells us we've successfully ran everything in this cell. So we've imported everything that we need. Now we're going to get started with cleaning our tabular data to start preparing it for machine learning. So the very first thing we need to do is load our data. So what we're going to do right now, we're going to use a sample data set. Like I mentioned to you all, the Titanic data set is very popular for like machine learning use cases online. Like a lot of people, when they're first learning machine learning, they end up using that data set. So it's actually preloaded into the Seaborn library. So what we're going to do here is grab, just for the sake of simplicity, we're going to grab 4 columns from that data set. We're going to grab their survival status, their ticket class, their sex, and their age. And we're going to store all that data into this variable named df. This df is going to be our data frame or table that's going to contain all the information that we're going to be cleaning. And I've just added some additional information for us to learn about the data set. So we're going to run the cell. The data is stored into the data frame, and we can see that our data set has 891 rows and 4 columns. And I'll point this out the reason I printed this out is that I want to bring the shape again later on. But here we can see the first 5 rows. We could see what our data looks like. We can see survival status, passenger class, sex, and age, as well as some of the values that each passenger would have for these characteristics. So I've also left a note here for you to access afterwards. If you're not using a pre-existing sample data set, you could load your own data, and I included the steps here for you. So the reason I brought up the shape of the data is that when we're working with machine learning, you are going to have to split your data set into a training set and a testing set. I'll go more into detail about that at the next workshop about machine learning, but basically what you need to know about like this training and testing split for today is that essentially when you're training a machine learning model, you're like training actually means let's look through our data and let's look for some patterns. What patterns can help me predict the relationship between, like in our case, it's going to be what relationships can I find between class, sex, and age to survival to be able to predict survival status for new unseen data. So we need unseen data. Like without it, we can't really test our machine learning model. So that's what our training and testing split allows us to do. Our training set is going to be what we're going to use to train our model, look for patterns, look for relationships between the input variables and the output variable that we're going to predict for. And then the testing set is going to be set aside, and we're essentially going to use that testing set as sample unseen data. We're going to pretend we don't know what those values are. We don't know if those passengers survived or not. we're going to treat them as new data points that we're going to feed into our model to see how it would perform in the real world. In this case, with the Titanic data, like you're not going to get new data because like the Titanic event already happened. But if you're doing something like forecasting or you're trying to predict for a specific disease, like let's imagine you're trying to predict, I know there's applications of detecting if certain medical images have an image of like a tumor or something like that. You need a training set to train what a tumor looks like and what not tumor looks like. And then you need a test set to treat it as new data that we haven't labeled at all, and we don't know what the outcome is. So that is why we're doing this split of training set and testing set. When we clean our data, we also need to do this split because if we do any sort of calculation or estimations for our data, we need to do it only on the training set, which is what we're treating as the original data set that we're going to look for patterns in. So I will show you on a table kind of what that looks like. But essentially in this step, first thing we're going to do is split the data. We're going to use a built-in function from sklearn to split our data set into 80% training data and 20% testing data, as we can see with this little parameter. And when we run this, we can see that we now have a training set with 712 rows and a testing set with 179 rows. Now that we've split our data, and I see a raised hand, give me a second. I think, can you unmute yourself, Amy?
Yes, can you hear me?
Yes.
This might be a trivial question, but I just wonder, what does random state do? I know it randomizes the data, but what does random state plays in this role? Like random up the data, or what does
Yeah,
it? Yeah.
great question. So when you are training and testing your data, when you're splitting your data, sorry, into training and testing, the computer randomly selects what 80% falls into train and what random 20% falls into test. But the computer kind of needs a seed to like start its like random number calculation. That's what this is. So essentially, every time you run your notebook, if your random state is always 42, you're always going to get the same split of testing and training data. If I come back another day and I set the random state to 0 or 2, it's going to give me a completely different split. Like a different 80% is going to fall into train and a different 20% into test. Um,
Thank
does
you.
that, of
Yeah.
course. Yeah, thank you for your question. Okay. And I know I talked quite a bit about like the training and testing split. I'm going to show you here with this next step why it matters. So one of the things that you have to consider with machine learning is imputing. So imputing means that you are handling missing values by like in this case, we have some records for passengers who did not provide an age. One option is drop the records of people who didn't provide an age. Another one is for us to make an estimation of that age. So how do we estimate the age? We look at the other people who were on the Titanic. We determine either the mean or the median. And then you kind of, any empty record or any record without an age, you assign it the mean value or the median value. Today we're going to go with median. So let me see where that would be. So I have this sheet that has 20 records just to quickly show you what that imputation would do. So let's imagine our data set has 20 records only, not the 800 and something. If we want to estimate the ages of these people, and we look at the age of everyone here, we would essentially grab all of these ages. Let me just delete these here. And let's see if it So it tells us that the average age in the data set is 22.9. So it tells us, okay, let's go ahead and fill in these values with 22.9. But if we take out the bottom 20%, which would be like 4, would essentially be these 16. Let's imagine these first 16 records, or this first 80%, is our test set. So if we calculate the mean age on this, I can probably just drag this. The difference is actually not that large. It's like a difference of about, well, 1 year. We could say 1 year if we're rounding. So if we average out with the entire data set of 20, we are essentially taking into account data that we are treating as unseen. So this unseen data for future predictions, is going to be influencing the average that we're going to be using to fill in these blanks. So we don't want to do that. That's why we went ahead and split into a training set and a test set to calculate the average age only based on the training data. And then we'll use this to fill in all missing values of the training data set and any future unseen data that might come in outside of just the test set. Any new data that you actually have to predict for in the real world, we would use this average, not this one. So I'll show very quickly here that before imputing, we have 140 missing age values in our training set and 37 missing values in our test set. We initialize our imputer, which is also built into sklearn. We tell it that we want to use our median as the strategy. So we wanted to calculate the median value and fill in the blanks just like I showed on the Excel sheet. And I want it to set any missing values equal to this median in our data set. So we'll run this. And when we impute, we're going to see that we no longer have missing values because they've been filled in with the average value of that row for the training set. One thing I want to point out here, if we look at the training set steps for imputation, we see we call our little imputer and we tell it to fit and transform. But for test, we only transform. Why is that? The reason is that we're telling it grab the training set age, fit means find the median value, transform means apply that median value to the empty cells. And then when we get to this one down here, we don't need to recalculate the median because we already got it up here. So whatever median you learned up here, just apply it. So here we learn it and we apply it. Down here, we just apply it. And that way we are essentially preventing data leakage from happening, where if you fit again here, you would be giving it information about what's considered to be unseen test data. Another step that you can take with data for machine learning is something called one-hot encoding. So one-hot encoding essentially converts text columns into numbers. And the way that it does this is, and we'll see it in the example, it essentially grabs one column that might have different categories as a possible value, and then it creates one new column of information for each of those possible values. So we can see here that we have 4 columns, and we have one column, the sex column, that has 2 values, male or female. As we can see here, we have 467 male records, 245 female records. But with some machine learning models, you can't pass in text information in your data because it's not really going to know how to handle it. So a lot of times when you are like training a machine learning algorithms, what it's actually looking for is for patterns in the numbers. There's different ways to look for the patterns, but it needs numbers to be able to calculate something. So if you give it something like text, it's not going to know what to do with it. It's not even going to know how to be able to calculate anything from text. So we need to take the pre-processing cleaning step of turning it into a number. So one way you could do this is, I don't have an example here, but if you have multiple categories, like let's say you're asking someone for their major, like we have engineering, we have sociology, we have physics, math. So that's 4 different majors. You could technically map 1 to engineering, 2 to math, 3 to social sciences, 4 to physics. But then again, when the machine learning model is looking for patterns, it's going to think that 1 and 2 are more similar than 1 and 4. We know they're not, but the computer, all it looks for is numbers. So if you add like ordered numbers to the categories, it's actually going to think, oh, whatever category is associated with 1 and 2 are more related than 1 versus 4. So one-hot encoding allows you to circumvent this issue by creating the multiple columns. So again, we're fitting and transforming on the trained data, and we're just transforming our test data. Don't worry about the syntax. It's like all of it is pretty much outlined on all of the documentation. And honestly, if you Google, how do I do X, like it's going to direct you specifically to the documentation point. Right now, I want us to focus on how it works. So what I'm essentially asking this is, grab the sex column, turn the categories into their own one-hot encoded columns so that the machine learning model can treat these numbers or take them into account into the calculations. So what we see here is that we no longer have the sex column, and instead we have 2 columns here, one that says sex male, one that says sex female. And when sex female is 1, we know the passenger was female. When sex male is 1, we know the passenger was male. So we've gone from this set of categories in one single column into numerical ones across multiple columns. And you can also tweak the settings if you want to, like for instance, here we know that if this is 0, then this is 1. And then if this is 1, this is 0, because we only have 2 categories. So there is an option in the settings for you to drop one of the columns. So we could essentially just keep like sex female, and we know, okay, anytime we see 0, it's male. Anytime we see 1, it's female. But this is more useful to have multiple columns when you have more than 2 categories. Next, moving on to feature scaling. So we have here many, like, kind of what I mentioned earlier, many machine learning models rely on calculating mathematical distances between data points. So if we are doing something like clustering or something like that, where you are looking at which data points are close to each other, or we need to look at the magnitude of the numbers, if we have a value that's 1 or 0, and then we have age that's from, let's say, 0 to 100. I think the max age here is like 90. The machine learning model might give more weight to this age characteristic only because it's a larger number, not because it tells us anything more, but only because the magnitude is larger. So one thing you can do is standardize the numbers so they all fall within a very similar scale. So we can grab our columns age and class to bring them down to numbers that could be closer to our categorical 0s and 1s. So I think I have here how it distributes. Yeah, so standard scaler essentially grabs all the numbers, looks at the distribution, and based on that distribution, it puts it on a, I would say like a bit of a chart, like with a mean of 0 and a standard deviation of 1. So we'll initialize our standard scaler. We tell it we want to scale our age and class. Again, we fit on train, and then we only transform on test. And when we run this, we can see that our ages are no longer 45, 23, 32. Instead, they are on that scale centered around 0 with a standard deviation of 1. So then this way, your machine learning model isn't just automatically going to give more weight to a specific feature only because it has larger numbers. It's actually going to give it more weight if it's actually a meaningful feature to consider. The last step I want to talk about regarding tabular data is balancing your data set. So in the Titanic data set, our target variable is imbalanced. What that means is that we have more passengers who died than survived. So there is like, let me see if I can print it out. Do I have it here? Let me just print it out here. So green, yeah. So we see here that we have 444 passengers who did not survive and 268 who did. It is imbalanced, one is larger than the other, but this is more apparent in things like I mentioned earlier, like in medical applications where like, let's imagine you're predicting for a disease that only has like only 1% of the data set has that disease. So 99% of the data set does not have the disease. So your machine learning model could actually learn to be lazy and it could say, okay, I'm going to train to get the best possible score. I'm going to predict that no one has the disease. Because if I predict that no one has the disease, I'm going to be right 99% of the time. But then what we actually care about is that 1%. But the model doesn't know that. It just looks almost like for the path of least resistance to get to the higher performance scores. So very similarly here, it could technically get lazy and say, well, I'm just going to predict 0 for everyone. And it's still going to perform like okay more than half of the time. But we want to avoid that by balancing the data set. So one thing you can do that's built into some Python libraries that we're going to cover today is called oversampling or generating random, what is it? Generating samples, samples, essentially synthetic samples. You generate synthetic samples based on the data that you have. So we have here our data. We're splitting it into X and Y. X being our input features that are going to help us predict our Y target variable. We do the same for test. We initialize SMOTE, which is our synthetic oversampling tool that we're going to use. Again, we set the random state to make sure that every time we run this notebook with the same random state, it's going to give us the same results. And then we go ahead and generate our oversampled test training set. So we run it, the green check mark tells us it's good to go. And we will see now that, oh no, why did it not run? Let's see. Okay. Yeah, here it is, sorry. So before smoke, we had 444 who did not survive, 261 who did survive. And then after smoke, after generating some synthetic samples, we see that this is balanced. And something that I want to note, I don't remember if I wrote it in here. Yes. So never apply smoke to your test set. Your test set should still represent the true real world population. So we only really generate synthetic samples for the training set, just so the model doesn't get lazy and like goes one way. We essentially give it more variations of what the minority class looks like. In our case, predicting death. We generate more samples, so it has more stuff to learn from. So we will go ahead and with that move on to our text data. So when I think of tabular data, you could primarily use it for well, you could use it for many things, but one of the main things you could think of is traditional classifier. So it might be something like logistic regression, or you might have heard of support vector machines, any sort of machine learning classifier that you could kind of get started to learn about machine learning will probably be a good idea to start with tabular data. So another sort of data that we can process is text data. So cleaning text data consists of separate steps from what we just covered. It essentially focuses on reducing noise and adding some structure to text to improve data quality and so that there's not so much variation between words, because as we know, like when we speak, in a language, there could be things in past, present, future, there could be commas, exclamation marks, and we are trying to kind of like bring the text down to like as like simple of a version as we can so the computer can do some work with it. So in, oh, I just noticed I put the wrong information. Sorry about that. Uh, where is it? Well, I overwrote a slide, it looks like. I'll update it before I send it out, but essentially when it comes to processing text data, the main things that we're gonna do, and you're gonna see them on the Jupyter notebook, you're gonna be doing things like removing punctuation, you're gonna lowercase things, and actually we have it here on the example. So we are gonna remove any capitalization, any stop words like did, so that we bring it down almost to like its core level of the words that we have present on the text. So for this, we're going to use the NLTK library, and I'll make sure to update the links before the slides go out. The first thing we're going to do, and for this case, we're just using a random sentence. Like the sentence says, the mission to Mars was a success. It was amazing. But we see that we have an exclamation mark, we have capitalization. So we're gonna take care of all of the, like removing all the fluff, I would say, to bring it down to like the core tokens in the text. So first thing we're gonna do is use this regular expression to remove anything that's not a letter from A to Z. I think it also removes so it removes all the characters that aren't just letters. And we're also telling it to grab the text and lowercase it. So when we run this, we can see that those steps took place. We remove punctuation and it's all lowercase now. The next thing that you have to do when you're working with some natural language processing tasks includes tokenizing. So essentially, and I think back to like pre-ChatGPT coming out to now, I feel like before ChatGPT like exploded, no one really knew what a token was, but now you might hear things about like, oh, it like sends X tokens or like the context sizes, whatever many tokens. For these natural language processing tasks, when we refer to a token, we're referring to a word. So we need to bring down the sentences that we have into specific like individual tokens or individual words. We use NLTK's built-in tokenizer. We give it our clean text. And we see now that instead of having one sentence altogether, we have a list made up of individual tokens, and each token is a word in this case. The next thing that we're going to do, like we saw on the slide, we are going to remove stop words, and we're going to load, I'll show you what it looks like. We're going to load a list of all the stop words in English. You'll see here what they look like. We have things like we, she'd, theirs, hadn't, about, they, than. So these are words that probably show up often in a text, but don't give us a lot more context about what it is that we mean in our writing. So what we're gonna do, we're gonna run a little loop that tells us check every word in this list up here, and keep it only if it's not present in the stop words. So when we run that, we are going to see that our sentence is broken down to mission, Mars, success, and amazing. The last step with natural language processing is a step called lemmatizing. And you're probably going to see two ways to do this step. One is called stemming, the other one is called lemmatizing. But essentially what lemmatizing does, it brings down the words to its root level. So if you write a story about, I don't know, running or baking, let's go with baking since I think you could conjugate it in different ways. So if you're writing a story about baking, you might say in one part like I'm baking a cake, and another one I baked X yesterday, or baking is great, and bake. So all the different variations of bake, which for us who speak like the language, would probably know that they all refer to the same action of baking. The computer, well, now with large language models, it probably knows the difference. But with, like, I would say other applications of natural language processing, you need to bring down all those different variations to one core like word. So in this example, I don't think I saw many changes, but you're going to see real quick how we are essentially we're initializing our lemmatizer. We give it our words, and it actually brought down Mars from Mar because it assumed that Mars is plural. But essentially, lemmatizing is going to bring it down to the root word. Um, the last sort of data I wanted to go through today is image data. So we're going to be using the Fashion MNIST dataset. Fashion MNIST is essentially just a dataset made up of clothing items, just like these. And this one can be used if you're training some sort of neural net or something that's gonna that you're trying to see like how it can classify images. When you process image data, you just need to make sure that all the data is like as standard as possible, that it has the same structure. So some steps you can consider includes resizing, grayscaling, reducing noise, binarizing, and augmenting your data. And we'll see how to do a couple of these in the slides. Very useful library is OpenCV. It has a lot of stuff built in for you to be able to do some of these steps and more outside of what I mentioned. And in the notebook, what we have for this is us loading, again, a sample data set of the fashion data. We can see that it's downloading the data. And in this training batch shape, it's telling us we have 60,000 images of size 28 by 28. In our case, this is 28 pixels by 28 pixels. And we'll see a little bit of what it looks like. So it tells us it's an array. We can see a tiny shoe there. Oh no, that didn't work. Let me see if this one might show a little bit better. Yeah, so we have a shoe and we have a shirt, but if you see, each square is a pixel. So really what the data truly looks like is just a bunch of numbers giving us information about the color stored into that pixel. So the computer grabs all those pixels and it turns it into an image. So us, like the non-computer, would essentially be more familiar with this, but the computer needs a numerical representation to be able to work with it. So the first thing we're going to do is define a cleaning function. For today, we're only going to do two things. We're going to explore thresholding, which essentially turns the image into pure black and white. So it's going to reduce any noise with gray. And dilation, which expands white pixels to make clothing borders thicker and more pronounced. This is also especially useful if you're working with something like numbers, where, like, let's imagine there's a scanned image of handwriting and there's a part where it's like very faint. So dilation might help. There's also the opposite. I forget the name of it, but like it might help with either sharpening the borders or thickening the lines. So today we're just going to do those two, turning it into black and white and expanding the white. So in this function, we are we're using our library, using the threshold function. We're passing in images, and we tell it the parameters that we want to use to, like, when you get to 127, that's going to be the cap to like either make it like all white or all black. And then over here, again, let's not focus too much on the what is it? The syntax. The main thing is we're using, again, OpenCV, the dilate function for the data that's already been thresholded. And we tell it to use a brush size of like 2 pixels by 2 pixels to generate the white borders. So it'll make a little more sense once we open up the images. But when we click the button here, we create our function. And down here, we're going to use that function, the image, to go through our set of 60,000 images and clean them up. So we're going to run that. And it tells us we've successfully cleaned all 60,000 images. And now we're going to compare a raw image with a clean image just to show you some of the things that you could do for image data. So when we run this, we can see that it started off as a t-shirt and it kind of got rid of any sort of gray in here. In this case, not that it would help, but I just want to show you how you can change your parameters for your specific use case. Let's say you want to use a thicker brush for like drawing the white. We rerun this. We reapply it to our data. Oh, now it just looks like a blob, but essentially that's how you can essentially tweak the parameters. And I feel like almost all the steps that we went through today are going to have parameters like that you're going to be able to change. Just like we were able to use median values for imputing our tabular data. You could change it to use mean values. You could change it to just default to 0, whatever it is that fits your specific use case. Let's bring this back to 2, just to see what it looked like again. Yeah. So that's essentially how you could process different sorts of data. I do have links to all of the documentation here for you. So we have documentation and cheat sheets for pandas libraries, scikit-learn. This is the machine learning one. Pandas is the tabular data one. NLTK is text, and OpenCV is images. And you can also use resources like W3 Schools and Geeks for Geeks to continue learning. I'm sure all of us are familiar with AI tools at this point. So Gemini, ChatGPT, things like that also help a ton. I like to use it. There's times where I look at the documentation and maybe I don't really know like what like changing a parameter might actually do. Like most of the time the documentation is very detailed, but like for the few times where like it doesn't make sense, I like plop it on Gemini and I ask it, hey, like what exactly is the difference between changing the value between mean and median? And it's actually going to outline everything. Or if you don't really know where the documentation is for a specific thing, or if you're trying to do something to your data, like let's imagine you want to impute your data set. You want to fill in the null values, but you don't know that it's called imputing. You could ask Gemini, hey, like I'm trying to fill in the null values in my data set. What is the Python function that I could use for that? And it's going to give you options there. So some tools for you to continue learning. And as I mentioned at the beginning, I'm the research data scientist here at the library, so I'm happy to help with any data-related questions you might have, from data planning and management to analysis and visualization, including questions like today, like data cleaning for machine learning, and ending with data sharing and repositories, depositing your data into things like Dryad.